I hope all of you are doing good. Let's start today's chapter, Decimal Representation of Rational Numbers. Introduction. In the previous chapter, we have seen rational numbers as a natural extension of the concept of a fraction. Also, we know that a fraction may be represented as a positive decimal number and that every finite positive decimal number can be expressed as a fraction. In this chapter, we shall extend these concepts in the case of rational numbers too. We shall see that every rational number can be expressed as a decimal number and that every decimal number having a finite number of terms in the decimal part may be converted into a rational number. Okay? Rational numbers as decimals. We know how to represent fractions as decimals. The same idea is applied in the case of rational numbers. The method involves the long division process. Consider an example. Convert the following rational numbers into decimals. For example, 2 by 5, let's convert it into decimal. Put a decimal here and add a 0. 5 fours are 20. Okay. So, the decimal number is 0.4. Okay. So, from these examples, we observe that every rational number can be expressed in any one of the following two types of decimals. Number 1, terminating decimals. Number 2, non-terminating repeating decimals. Number 1, terminating decimals. The numbers with the finite number of decimal part are known as terminating decimals. These decimals terminate after some steps and hence called terminating decimals. Examples, these are the terminating decimals. And number 2, non-terminating decimals, repeating decimals. In this type of decimals, the division never comes to an end and a digit or a block of digits repeats itself again and again. In such manners, the division never terminates. For example, all these decimals are non-terminating repeating decimals, and these decimals can be represented by putting a bar or dot. For example, 0.3333, we can represent it as 0. By putting a bar, or you can also write 0.3, right? Example, express each of the following rational numbers as decimals. You have to divide 8 by 3, okay? 3 2s are 6, 2 decimal 0. 3 6 are 18, 2 3 6 are 18, 2 3 6 are 18. Okay, this division never going to end. So this kind of division is known as means this is the decimal which is non-terminating repeating decimals. Okay, quick check for terminating and non-terminating decimals. From the given examples, we observe that when the denominator of a rational number is a standard form, lowest term, has no prime factors other than 2 or 5, then the rational number has a terminating decimal value. Example, 15 by 8. Number 2, when the denominator of a rational number in standard form has some prime factors other than 2 and 5, then the rational number has non-terminating decimal representation. Keep this in mind. Okay, for example, 12 by 7, 8 by 3 and 13 by 11. All these are prime numbers in the denominators. Okay, so have denominators with factors other than 2 and 5 and hence have a non-terminating decimal representation. Okay, example 1, without actual division, find which of the following numbers are terminating and non-terminating. Okay, first is 7 by 15. Okay, factors of 15 are 3 into 5. 5 is okay, but 3, it has a prime factor. Okay, so it is a non-terminating decimal representation. Then 4 by 125, 125, factors of 125, 5 into 5 into 5. Okay, only 5. So this is a terminating representation, decimal representation. Okay, 34 is 7 by 34. 34. So 2 into 17. Okay, 17, it has a prime factor, so it is also a non-terminating decimal representation. And if we talk about 87 by 6, factors of 6, 2 into 3, here 3. So it is also a non-terminating decimal representation, right? Exercise 4.1. Convert the following rational numbers into decimals. 4, we have to divide 17 by 4. 4 4s are 16. 1 decimal. 4 2s are 8. 2 0. 4 5s are 20. So the answer is 4.25, right? Next, conversion of decimal numbers in the form of a rational number. We have seen that a rational number can be converted either as a terminating decimal or as a non-terminating repeating decimal. Likewise, we can convert a decimal fraction into a rational number. Conversion of terminating decimals into rational numbers. When we want to convert a terminating decimal into a vulgar fraction, we put 1 under the decimal point in the denominator and add as many zeros as the number of digits after the decimal point. Now remove the decimal point and convert the fraction into its simplest form. Okay, for example, 0.3 is what? 3 by 10. Okay, 1.25 is what? 125 upon 100. Why 100? Because there are 2 decimal places, right? Conversion of recurring decimals. Recurring decimals are of 2 types. Number 1, pure recurring decimals. A decimal in which all figures after the decimal point are repeated is known as a pure recurring decimal. For example, these are pure recurring decimal. Number 2, mixed recurring decimal. It is a decimal in which at least one figure after the decimal point is not repeated and then some figures or figures are repeated, is known as mixed recurring decimal. For example, these are the non-recurring decimal, mixed recurring decimal. Now converting a pure recurring decimal into a rational number. We shall explain the procedure with the help of examples. See, convert the following decimals into rational numbers. Okay, 0.6 and then there is a bar. Okay, so let x is equals to 0.6, there is a bar. Okay, then x is equals to 0.666. Okay, this is equation 1. Here we have only one repeating digit, so we multiply both sides by 10 to get, means we will multiply this equation. So 10x is equals to, if you multiply this by 10, what will you get? 10x is equals to 0, no, now not 0 because this decimal will shift here, 6.66. This is equation 2. Now we have to subtract 1 from 2. Okay, so 10x minus x is equals to 6.66 and then dot dot so on minus 0.66. Okay, so you get 9x is equals to almost 6. So x is equals to 6 by 9, that is 2 by 3. Okay, 9. Now writing rule. To convert a pure recurring decimal into a rational number, we write the repeated figure only once in the numerator and take as many as times 9s in the denominator as the number of repeated digits. Now converting a non-terminating recurring decimal into a fraction. Now consider this example. Now let's move on to next example. 0.36 and then there is a bar. Okay, so first you will multiply this by 10. Okay, so you will get, decimal will shift here, 3.6, then there is a bar. This is equation 1. Then multiply by 100 into 0.36 bar, you will get 36.6, then there is a bar, 2. Now we will subtract 1 from 2. Okay, so what will we get? 90 into 0.36 bar is equals to 36.6 bar and minus 3.6 bar. Okay, so if you subtract this, you will get a 33. Okay, so 0.36 bar is equals to 33 by 90. Now 3 ones are 3, 3 ones are 3 and 3 zeros. So this is 11 by 30, right? Exercise 4.2. Express the following in the rational form. 0.7 is 7 by 10. Okay, 0.35 is what? 35 upon 100. Okay, because there are 2 decimal places, right? Things to remember. Every rational number can be expressed as a decimal. 2. The decimal representation of a rational number is either terminating or non-terminating repeating. 3. If the denominator of a rational number contains no prime factors other than 2 and 5, then this rational number can always be expressed in terminating decimal form. Otherwise, it is expressed as a non-terminating repeating decimal. Students, I hope you have understood this chapter and keep doing practice of this chapter.